Oh my goodness. I am going to give myself 20 minutes of peace and quiet away from a family party that is happening downstairs. Molecules don't try to set you up on blind dates. Molecules don't ask you to rush to Costco to buy a box spring that's on sale. For the next 20 minutes, I am going to enjoy giving the proper nomenclature to these cycloalkanes. In this ACE session, Assistance with Chemistry Exercises, we will name the following cycloalkanes and use the cis-trans notation when appropriate. Let us start with molecule A. The first step is to number the parent. We are going to assume that the parent is a ring. I'll show you one example at the end where the parent is not the ring. And we want to number the ring in such a way that the first and second substituent is as low as number as possible. In a ring, the first substituent should be on carbon number 1. So yes, we are going to focus on the second substituent and get that as low as number as possible. Here I give two ways to number the ring. The first way, I put what a lot of students would tend to put, with carbon number 1 being at the top. Also, they may think that because ethyl comes first in the alphabet, it should be number 1. Here on the right, I numbered it a different way. Let us locate where every substituent is. And again, it's only based on the location for now, not on the alphabet. Here I listed the 3 substituent locations for each of the molecules. What we notice here is that the first substituent occurs on carbon number 1 for each numbering system, but the second substituent, there's a difference, and it's the one on the right that is numbered properly. Next, we are going to circle the substituents. These are the carbons that don't have a number. These are the carbons that are not part of the parent. So here, arrows show you how I determine what the winner was, or what the winner is. It's the one on the right, and now I circle the substituents. You want to make sure that when you use the dotted circle method, that you bisect the bond and don't have the dotted circle come anywhere close to a carbon that's part of the parent. You don't want to get confused. A carbon can either be part of the parent or part of the substituent. The next thing is to list the substituents and also list the parent. The parent is cyclopentane. You notice also that when I listed the substituents, I put their location. What's interesting about this molecule is that it has 2 methyl groups. We will call that dimethyl, and you have to locate both methyl groups, 1 and 2. Even if both methyl groups, not in this case, but even if both methyl groups occur on the same carbon, for instance carbon number 1 with the second methyl group, you will still have to say 1, 1. A bit later, we'll see an example of that. Next is to put the components of the name in the correct order. The parent comes last, and now the substituents are alphabetized. So they are put in alphabetical order, not in order of their number. The proper IUPAC name for this molecule is 4-ethyl 1,2-dimethyl cyclopentane. Put a dash between every number and letter, put a comma between 2 numbers, and there should be no spaces in the name. It is alphabetized also based on the letter E for ethyl, but when you have a Greek prefix like di, tri, tetra, that is not alphabetized. You go by the root, in this case M for methyl. Example B looks simpler, but there is one important rule when you only have one substituent on a cycloalkane. Let's number the ring first, and also circle the substituents. Obviously, because we only have one substituent, it will occur on carbon number 1, and the rest of the numbering doesn't matter clockwise or counterclockwise. It just shows us that we have a cyclobutane ring. The other thing is that we have a branched substituent. We call this isopropyl, an isopropyl group. It is a common name, but it is acceptable by IUPAC to put in the official name. There are other systematic ways to name these branch substituents. We'll go over that for this one in just a bit. Here I have the name isopropyl cyclobutane. What do you notice? We did not put a 1 in front of isopropyl to give the location, because by default, since this is a monosubstituted cycloalkane, the substituent should occur in carbon number 1. It is not proper to put 1. Now I mentioned that there's a systematic way to name this branched substituent. That way is 1-methylethyl cyclobutane. 1-methylethyl is the same thing as isopropyl. The way you get this is that you number the branched substituent as number 1 at the point of attachment. You find the longest chain, which is 2 carbons, and the branch has its own branch. It has a methyl group on carbon number 1. Hence, we have 1-methylethyl. Notice that we don't say 1-methylethane, because those 2 carbons are not part of the parent. They're you can think of it as the parent of the branch. Okay, what is the issue here? We have labeled or named a cyclopentane with 3 substituents. Remember I think it was letter A, where we had 2 methyl groups. Well, in this case, now it matters whether we number the ring 1, 2 from left to right, or 1, 2 from right to left. Let me set up that numbering system and then we'll analyze. Here I give 2 ways to number the ring to get the first substituent on carbon number 1 and the second substituent on carbon number 2. What's the problem here? You notice that in both cases, we get a substituent also on carbon number 4. It is a complete tie in terms of location. What do we do with a tie? We ask ourselves, well, for carbon number 1, we're going to put the substituent that is first in the alphabet. Okay? For here, carbon number 1 has a bromine. On this molecule, carbon number 1 has a propyl. Bromine comes first in the alphabet. What do you notice? We are unconcerned about the ethyl group because it is on carbon number 4 in each case. Okay, I got rid of the loser, and now we see that the numbering starts with 1 bromo because it beat out the other numbering system which had 1 as propyl. What's next? You know what's next. We're going to circle the substituents, list the substituents and the parent, then put it all together in the name. If you want to give this a go, pause the video and based on my numbering system, our numbering system, go ahead and name this molecule. The name of this molecule is 1-bromo, 4-ethyl, 2-propyl cyclopentane, and I'm pointing to the letters that we're using to alphabetize the substituents. Okay, D is a bit more complicated. Do you know how to number this ring? Here I propose 2 numbering systems. Now based on those 2 choices, one of them is correct. Please list the location of the substituents on each choice, pick a winner, circle your substituents on that winner, give the list of substituents with its location and the parent, put it all together into a final name. Go ahead and take a minute for that. Okay, did you pick the right molecule as the winner? Because when you have 2 substituents on a carbon for a cycloalkane, most likely that's going to be carbon number 1. You are counting it twice. 1, 1, 3, 4. You know, in the numbering system on the left, the 2 alpha groups occur on carbon number 4, and we would list the substituents as 1, 2, and you list each alpha group 4 and 4. By the time we get to the second substituent, so technically the second substituent is the second alpha group, still on carbon number 1. That means that this will be the winner. And how do you list the substituents when you have multiple? You use a Greek prefix, di, tri, tetra, etc. You have actually 2 ethyls and 2 methyls. Put the name together, don't forget the numbers. See, this is the example I was talking about when you have two substituents on the same carbon. You just can't say one diethyl. I know it's pretty obvious that, well, no, it's not obvious actually. You need to explicitly tell us that the ethyl groups are carbon 1 and 1. Just like here, you explicitly tell us that the methyl groups are on carbon 3 and 4. Yes, E has wedges and dashes. This is potentially a case where we're going to have to use system fans. Now also, we have to number it properly. This is not as easy as it looks. Again, the numbering is based on getting the first and second substituent as low as numbers as possible, but something, again, happens here that we've seen before. Yes, we have a tie again. We only have two substituents, and they're right next to each other. Naturally, they're going to be 1 and 2, or 2 and 1. Remember, when you have a tie, in terms of numbering, then and only then do you go to the alphabet to break the tie. Fluoro comes before propyl, so we're going to put fluoro on carbon number 1. How would you name the molecule now, based on that? If you put the name 1-fluoro, 2-propyl cyclohexane, you'll get partial credit in my class, but because we're showing wedges and dashes, we're showing direction of these two groups, one towards us and one away from us. We're going to use cis-trans notation based on the following rule. When you have two substituents and it's clear that they're showing direction based on wedges and dashes, we're going to remember cis same side, trans is opposite. Because one is towards us and one is away from us, we're going to indicate that this is a trans disubstituted cyclohexane, and you put normally at the beginning and normally with italics, but if you're handwriting this, don't worry about the italics. There is a dash still between the letter S and the 1. The name for this molecule is trans 1-fluoro 2-propyl cyclohexane. But there's a twist. Let me show you that. What's the twist? Look at this second molecule here. One's dash, fluorine, one's wedge, propyl. So that also is trans 1-fluoro 2-propyl cyclohexane. I thought IUPAC was supposed to give us rules, so there's one name for every one molecule and one molecule for every one name. So we can't have this ambiguity. If you read trans 1-fluoro 2-propyl cyclohexane, you got to know which is which one do they want. And if you're very good with stereochemistry, a unit after this one, you will know that these two are actually different. If you make a model, these two are not identical. In that stereochemistry unit, you're going to learn how to label these carbons as R or S. Don't worry about what that means right now. But if you have been studying stereoisomers, this one right here would be 1S, 2S, 1-fluorocyclohexane. Okay, so we get rid of the trans, and we put the indication of its what's called chirality. The original molecule up here would be 1R, 2R. So we're just labeling the carbon and its RS designation. Okay, F has two substituents, a chlorine, and let's go with the common name for this branch substituent, tert-butyl. Why did I put this example? It's another example where we have only two substituents, so we will be going to the alphabet. I wanted to give another example of the opposite orientation. This is now cis. Also, I wanted to give you another example of dash and wedges with an alkyl group, because the way to draw this is to draw the wedge or dash, and then all the other bonds are just lines. Go ahead and pause the video and try to name this molecule. You see how I still am numbering my parent, at least the carbons that have a substituent, and I am circling the substituents. This is a good habit to get into, even if you think you have a very simple molecule to name. The name of this is cis 1-tert-butyl 2-chlorocyclohexane. Again, what are the alphabetizing rules? You don't alphabetize based on di, tri, or tetra. This is a weird one. When you have a group, we have a tert-butyl group, and it has a hyphen, you alphabetize based on the root, butyl in this case, not the prefix. Okay. I think we had an isopropyl group before. When you alphabetize isopropyl, you alphabetize based on the I because there's no dash between iso and propyl. I know it sounds weird and kind of unnecessarily complicated, but those are the rules. I think we have possibly one more. This is interesting because we have 3 substituents, we have wedges and dashes, and there is a problem. The problem is, how do I label it cis or trans? Because cis and trans tells me the orientation or the relationship of 2 groups to each other. What I have written out here is we will not use the cis-trans notation because we have 3 substituents, and the methyl and ethyl are cis to each other, but trans to the tert-butyl. So what do you put at the beginning of the name? You don't. But we can still number it properly, number the ring properly, and put the name together with the substituents in alphabetical order. You want to give this a shot? Do not worry about cis and trans. Go ahead and pause the video and try to name this molecule. Once you have established a numbering system, I think the rest is easy. You alphabetize based on B, E, and M. 2-tert-butyl, 1-ethyl, 4-methyl cyclohexane. Oof. Now, if it's essential that we get every wedge and dash correct, your professor may ask, make sure you point out the stereochemistry, which is the R and S notation. Oh, made a mistake. That should be a 4R, because we have substituents on carbon 1, 2, and 4. Now I just want to make sure that it is R. Priority number 1, priority number 2, priority number 3, clockwise. Okay. Again, if you haven't got into stereochemistry or studied it very well, you may not know how to do this just yet, but you will. Stereochemistry is a very big part of organic chemistry. We do have actually one more. We called it the bonus. Here's the bonus. It's unusual because the alkyl chain that looks like a substituent off of the ring has more carbons than the ring itself. The rule is, if there is an alkyl straight chain that has a greater number of carbons than the cycloalkane, then the alkyl chain must be used as a parent. Now, if it's a tie, then the ring would be the parent. But I think we have more carbons along this straight chain than the ring. How are we going to deal with that? Let me number the ring. Let me number the parent and circle the substituent. You see how I didn't number the ring? The alkyl straight chain has more carbons, and it's a hexane. Okay, and we're going to treat this ring as a substituent. The substituent can't have the suffix ane. That's only reserved for the parent. So take a look at how I would name this molecule. The parent is hexane, and off carbon number 2 we have a substituent. The substituent happens to be a ring, a cyclobutane ring. But you don't use cyclobutane because it is a substituent. You will use cyclobutyl. The substituent is a 2-cyclobutyl group off of the hexane parent chain.